Hello. Okay. I have volume.
So I guess we'll get started. Good morning. My name is Ross Ortega. I'm a program manager in Windows Networking Core. We're here today to talk to you about what we've done in PowerShell. So just briefly before we get into that, just give you some background on me. In Windows 7 Server 2008 R2, I did a lot of performance tuning on 10 gigabit Ethernet, and it was hard. It was hard to configure the networking subsystem. For Windows Server 8, been looking at how we can make that manageability better. Also looking at things like Hyper-V network virtualization, and you can see how you'll see a thread through that, how we use PowerShell to manage all our features. On stage with me is Chris Palmer.
Hi, everyone. So I'm Chris Palmer. I'm a program manager in the networking core team, and I work on stuff you're going to see today, as well as some other stuff for direct access.
Great. So let's get into this, and I'll kind of lay out the context for what we're going to talk about. At this point at Build, you should know that we really care about the cloud, right? So Windows Server 8, cloud optimized, and what does that really mean? And what are the capabilities? So we introduced a new networking technology, Hyper-V network virtualization. So seamlessly you can extend an on-premise data center into the cloud. That's all managed by PowerShell. So very simple to use that. We've introduced things like secure isolation. We've introduced new features around the Hyper-V extensible switch, PVLAN, port mirroring, port ACLs, all these features, QoS, VM QoS, so QoS on the switch ports. All of those features manageable by PowerShell. So that will be the theme here. So how do you manage Windows Server 8? And quite honestly, in this talk, so we'll really be focused on managing the networking subsystem for the data center. And so that's really the context here. We've done a lot of PowerShell. We'll talk a little bit about some of the other PowerShell, but for this talk, really networking and Windows Server networking is the focus for us. And really building upon WMI v2 and PowerShell. So the agenda here, we want to not make too many assumptions about the background on PowerShell, so we'll give you a quick overview of PowerShell concepts to make the rest of the talk relevant. We'll talk about the power of using objects in PowerShell that creates and enables some very interesting new scenarios. So in terms of the audience, what we're looking at are those that are building management solutions for the data center, those that are building systems for the data center, so OEMs, those that are providing NICs for the data center, and being able to give you a way that you can fine-tune your products, building upon the PowerShell. I can almost hesitate to say this, but what we've given you basically are some very powerful primitives. And the reason the hesitation on the primitive word is because they're very powerful. You can do a lot of things without this. But it's also extensible, it's standards-based, so you can build upon what we're giving you. And that's what we want to do. And the reason we're really excited to be here about this is that we've gone and shown people internally at Microsoft that are running our data centers what we've done here. And as a server person, rarely do you get to make people just smile, right? I mean, people think, oh, that's kind of cool, oh, great scalability, 10 gig line rate, all that kind of stuff. But you're never going to delight them. And you'll see this. We've actually delighted people with this. And the opportunity here for you is to build on top of this and really provide some really interesting kind of applications at scale based on the PowerShell that we're giving you. And we'll give you some demos of things that we built kind of on the fly for fun, just to test this out and just to give you a feel for what it is, and then show you how we can do that. So we'll go from the object to the developer platforms. Standards-based, which means we're all about choice. So using the development platform of your choice, building upon the PowerShell that we'll give you, and then we'll put it all together, and we'll create kind of a little corporate network, all with PowerShell. Kind of a bare metal installation, popping up VMs and configuring all the networks, all with the PowerShell script. Like a minute or two that it'll take to run, and we'll build that all up. So what we want you to do is build on top of what we've given you, really. So we'll give you, what we want you to leave with is how you can manage and optimize your products. And that's really important. The nice thing about this is all in-box, Windows Server 8. So for your customers, you can provide these scripts to them. They run everywhere. They run remotely. You can just give them on your website or whatever mechanism you want to your customers. But this is where you can fine-tune them. And we really want you to build upon the PowerShell. And I'll talk about this as we go through examples. So let's just take a step back and let you know our thinking about how we got here. So traditionally, in Windows, you would TS into a box and manage it that way. You'd use a UI for that. But that doesn't really work anymore at scale. So when you start talking about cloud scale, so when you have hundreds of servers, thousands of servers, even greater, and then have VMs on top of all that, it doesn't make sense. You can't even think about really going in and TS into every single box. Now, we have products that let you do that, and that's okay at a smaller scale. But at cloud scale, how do you manage the entire data system, the data center? And one of the things that was hard and challenging is that there are some low-level features like around the NICs and NDIS, if you're familiar with that. You just couldn't get to it. You had to use the UI, and that was unfortunate. So we'll show you some demos of how we can manage that at scale. So this is very exciting because we took a holistic look at networking and said, we need to make this scriptable. It has to be remoting, so support headless, so it supports server core, and then we can do this at scale. Now, I'll really focus in this talk, and we'll focus on this talk, on Windows Server 8 management in the data center, but it's not SKU specific. So Windows 8 also has PowerShell. So if you wanted to manage your Wi-Fi NICs, the PowerShell that we're showing you can also be applied for that. I mean, we had no bias there, but our focus really was how do we do data center management. From our perspective, we wanted to give you a platform that was extensible that you could build on top of. And again, coming back to standards-based. So that was very important for us. And we'll show you some hooks that we put in on how you can build upon the PowerShell that we're giving you to extend it. And the advantage of that is that now Windows is managing a lot of the remoting things for you, so you get that for free. And also some of the things in the registry, we don't want you to go in the registry anymore. Let us handle that. It's always, problematic. But now that's all abstracted away. And so before, if you're familiar with playing around with advanced properties of the NICs, for instance, you'd have to go deep into the registry hive. You had to know, like, the GUID ended in 72. Now, that's kind of crazy. I mean, that's just bizarre, right? But we taught that to everybody, unfortunately. That's all going to be gone. The 72 is still there. You can still see it, but we'll track where things in the registry go for you. So that's all abstracted away for you. We'll deal with that in our PowerShell. So the message here is really to take advantage of what we're providing you in terms of the networking PowerShell across the entire networking stack. And I'll give you a quick tour of what we mean by that, how we went through all of the networking stack to do some management. And really, what we really want you to do, one of the messages, is to start, if you're using NetSH, NetShell, we really want you to start moving away from that. That's still in the product, but all our new features, our preference is very strongly on PowerShell. So every new feature that we've developed and announced at this show on the Windows Server side is manageable via PowerShell. That was almost a directive that we had, and we've accomplished that. So PowerShell is the direction that we're driving for managing networking. So to kind of make this real, what we wanted to do is show you a demo of what's possible. So this is something that Chris put together in a couple days just to say, hey, how can we show people what we've done here in the PowerShell? So Chris, why don't you give us a demo?
All right, I am going to switch to the right computer. Then you guys can see it. Okay, we're good to go. As Ross mentioned, this is a really simple app we built in basically a day, and it's just an example of a .NET application leveraging PowerShell to do a couple of useful things that we use for self-hosting back in Redmond. So let me just run the app. Oh, it's nice and fast. So this is what we call Network Manager. We just use it to basically test things and drive load against our PowerShell work. I just want to manage the local host machine. Okay, and for folks who might have managed network adapter events properties in Windows 7, you could change events properties as click and go, and you can see them on one machine. Here we've extended that ability using the PowerShell to include remote machines. So I can go to network adapter. I can see all the NICs. I can see all the events properties, all the values. I can change them. And this works, obviously, against local machine, but as well as remotely, right? And this all for free. We didn't build any special remoting stuff in this app. And we'll show you some of the code later used to power this kind of thing. The other thing I wanted to show real quick is things like getting all your IP addresses. And again, it's not just network adapter. It's the entire stack that we really brought and exposed through PowerShell. And so you can just go here. You can see even the command that used to get this, these objects, and it's this getNet IP address, SimSession localhost, and alas, there's all my IP addresses. So it's a really powerful foundation that you can build your own applications, your own scripts, to really deliver even higher abstraction solutions for customers. It's pretty cool.
Great, thanks, Chris. So this is not in box. This is just a sample app to show that. So it kind of looks like our UI. We did that on purpose just to show you what it could look like. But all that you saw right there was calling the PowerShell underneath. So you can very easily build data center management tools or other kinds of tools calling that PowerShell. And Chris mentioned how quickly it was able to do that. And throughout this talk now, we'll start showing you how we actually built that and go through some of the commandlets and discuss some of the power that we get from PowerShell for data center products. So again, in terms of Windows 8, Windows Server 8, PowerShell, is everywhere. And so again, we'll focus on networking, but also Hyper-V. Everything in Hyper-V is managed by PowerShell. File services also by PowerShell. So that's the big theme. So even though we're focused here on networking, if you're doing a complete all-up data center management tool, it can all be PowerShell based. So let's take a quick tour of the world of networking from our perspective. So I'll spend a lot of time on NetAdapter because that's kind of the base primitive that you need connectivity to start scaling up to the data center. But we've introduced, I mentioned some early features. So like NIC teaming is now in box. We have a UI that we've shown that's built on PowerShell. That is in box. But if you didn't want to use that UI, you can still manage it your own via PowerShell. QoS, quality of service, both native, so the native path, the parent partition, non-Hyper-V role, you can use PowerShell for that. You can manage the switch that way. So with QoS, we have QoS on both sides. All the offloads of the NIC, you can manage this. And as Chris mentioned, TCP/IP, if we start climbing up the stack, if you want IP addresses and routes, neighbors, things like that. Virtualization, again, we announced Hyper-V network virtualization, all PowerShell. Extensible switch, our switch now in Hyper-V, third parties can build on top of that and extend it. That also is managed by PowerShell. The firewall rules, IPsec rules, and then kind of higher level concepts also, like DNS and DHCP, branch cache, managing branch cache, managing a direct access. And for us, that's also very important. We see the hybrid cloud. The cloud's really about the hybrid cloud, which is going to generate a lot of WAN traffic. Again, so branch cache and D8 are very important in those scenarios. Again, managed by PowerShell. So let's just take a step back and talk about PowerShell. And this will again be in the context of networking. So if you're not familiar with PowerShell, it's a very simple concept. It's human readable. So you can say something like combining a verb with a noun. So here's an example of get NetAdapter. You might have done something like enable NetAdapter, reset-NetAdapter. So it's a really simple concept, the verbs and the nouns. So this is important because we focused on what nouns do we need to provide and what verbs so that you can do the common operations and to configure and manage the networking subsystem. So here are just some of the nouns that we've introduced: NetAdapter, DNS, the NetIP interface, and you'll see predominantly the prefix to the commandlets that we do start with net. And so that'll be important because it'll make it very easy for you to search and discover the commandlets that we give you. We'll show you some examples of how you can go out and find all the commandlets that we have in box. So, and here's how we do that. So if you were to type git command *-net star, and one thing that PowerShell gives you is wildcarding. And so you'll see a lot of wildcarding in here, so you don't have to type as much. But this, by prefixing here, you'll get all the networking commandlets with the net star. And then this is how you would get help, so you just type git-help. But one thing we should mention is when you use the networking commandlets, predominantly, you should be using them at a administrator prompt in PowerShell. So we do follow the same security model as you get in the user interface. So if you can't do it in the user interface without admin credentials, you can't do it PowerShell as well. So it's a similar security model. And there's some interesting things here. So get help on a particular commandlet, or show command will actually bring up a UI and show you what all the options are. Now, remember, we caveat all this that this is a developer preview, and so there's not a whole lot of documentation in there. So primarily the documentation is just the syntax, the names of the parameters, but we don't yet have inbox or documented publicly what all those parameters do. Now, our hope is that they're mostly intuitive, what you want, and you'll see some examples as we go through the commandlets, but that documentation is coming. But if you do run into problems, our contact info is here. We'll give an alias, and we'll definitely help you to start building your applications on top of the PowerShell. So remoting. Remoting is very, very important, and it's also very, very simple. So the remote management is on by default. So if you're domain joined, it's not a problem. If you're just using localhost, we have a way to get that working as well. Basically, all you do is pass -sim session as a parameter, and then remoting works. It just works. I mean, this is really, really powerful. So let's say I have two servers. I'll call those servers SQL1 and SQL2, and I want to see all the NICs on those two machines. And these machines are somewhere out in my data center farm, and all I know is their names. So I'll just say get net adapter -sim session SQL1, SQL2. That's it. I've now gone out, remotely queried those machines, figured out what NICs they were, sent that information back, and then we'll list it out. So we'll list a lot of the properties there. So we did spend a lot of time focused on these get commandlets. So that's retrieving the information. So as long as I have secure credentials on those machines from the command prompt I'm in, I just get that. That really is how simple it is. It's almost unbelievable how simple this is, right? And so you need to try it when you go home and set this up. We gave out the server bits as well, Windows Server 8. But it really is that simple. And that's why we're so excited that just running something that simple, I can start building up and managing a complete data center at scale with the PowerShell. So let me just talk a bit about NICs, because we have a lot of different ways to name a NIC in Windows. And it's just because historically and backward compatibility, we did this. So the names of the NICs by default now are called wired Ethernet connection. So for instance, if I have multiple NICs, I might have one called wired Ethernet connection 2. All our commandlets support wildcarding, so we don't expect you to actually type that all the time. So you could say W*2, and again, I mentioned on the client side, I can say Wi-Fi star, things like that to get the NICs and the NIC properties. Another thing, and this is very important, particularly for NIC manufacturers, but also OEMs and others just managing a particular brand of NIC. There's something called interface description. And if you use the UI today, you would see that. It would be the brand of your NIC, and typically it's speed and maybe an instance number with that. So that interface description is important because you can leverage it in interesting ways. So suppose I'm the Fabricam NIC company, and I want to provide scripts for Fabricam. I can do that by just getting them. Or let's say I'm an OEM and I want to look at those Fabricam NICs. I can say get net adapter -interface description Fabricam star, and I'll get all the Fabricam NICs. So you can now manage NICs by vendor very, very easily. So everybody that's manufacturing NICs and the OEMs as well, we want you to be aware of that. So if there's something specific to a particular NIC that you want to tweak for some reason, you can do it this way. And so we also want to encourage all the manufacturers that they're testing with these commandlets to make sure their NICs show up properly with these kind of things. So this will be our guidance to everybody and how they start managing NICs here. So the interface description, and I'll come back to that, why that's some more examples of how we use that. I mentioned extensibility. So again, before you could never manage these lower level NIC properties. And it becomes important for the data center, excuse me, at scale to do this. And so that's why I'm spending some time on this lower level thing as we start climbing up to data center scales. So the common things that we support, standardized keywords, things like RSS, VMQ, checksum offloads in the NICs, we have higher level support for those. So I could say something like enable netadapter RSS, enable netadapter VMQ. These are very important scalability offloads for us to get to 10 gig line rate. both on the native side and the Hyper-V side. So those, we understand, they're standardized keywords. There's certifications that you need to get for your NICs on those. But there's other value-added opportunities that the IHVs, the NIC vendors provide for their particular NICs. And there's no uniform way to manage those. And our message here today is to say, even though semantically we don't know what's going on, because they're not the standardized keywords, we want you to use our PowerShell to manage that. So here's an example. Suppose you're the Fabricam company, you have a 10 gig NIC, and you have something called ultra low latency mode. And I just made this up, so hopefully it makes sense. But let's say I have this. Now, you may have your own property panes and things to manage this, but we want you to use our PowerShell for that. So here's one way you can use a commandlet to do that. So you would say new net adapter advanced property. It's for your NIC. You know interface description. You know it's your NIC. And we'll put this stuff in the registry. So that number 72 in the registry hive and there, and the right spot, this keyword will go in there for you. So we'll put the keyword ultra low latency mode. We'll put the value in 2. This is up to totally arbitrary what you want to put in there. And you see reg string, basically, reg SC. That's exactly what it looks like in the registry. You know, the names. So we try to keep the names as close as possible so it'd be familiar to you. And then I'm doing this remotely. So this would be an example of how you can remotely manage your NIC for some property that Windows semantically doesn't know about. But you can use remoting, and you get all these benefits there. So you could build a UI for your customers to configure your NICs in particular modes using this. Now, this is kind of low level, this net adapter advanced property, but you can put syntactic sugar on top of this. So you can say, Fabricam super cool low latency is the commandlet that the user sees, but underneath it's calling this net adapter advanced property commandlet. So that's what we mean by extensible. Semantically, we don't know what's going on here, but we want you using it this way so we can kind of standardize and let Windows take the burden of managing those properties, where they go in the registry hive, and you get remoting on top of this so that you can now manage at scale. So let's say I have a data center rack. I have like 40 machines or in a rack, and I want to manage this. I can now set that property on all those machines remotely with this one line. Here, you know, I put more instead of the SQL 1, I put all 40 machine names in there. Boom, we'll pass it out there, and now I have all my NICs configured in a particular way. So we really want to encourage you to build upon what we've given you here and let us take the burden and then get the advantages from it. And again, Chris will walk through how you can build a UI on top of this to manage something low level like this. So I've kind of said this, but I'll just say it again. Take advantage of interface description. Make sure that works for your NICs. Use the net adapter for non-standardized properties. And we have a whole bunch of commandlets I was mentioning, like net adapter RSS, net adapter VMQ, the checksums, net adapter IPsec offload. All the things that we support, we provide higher level commandlets for them. So I also want you to go and discover those. And those typically fall in the format of net adapter, XXX, or XXX is the wildcard, like RSS, VMQ, and so on. So that's how we see an opportunity for the NIC vendors to build upon what we've built in box to manage the data center at scale. Now suppose you're an OEM. The OEM, you know what's in your particular SKU. You know the memory configurations, the motherboard configurations, you know what NICs are in that product. So you have a lot more semantic knowledge than we do. And you know how you can now optimize it, or how it should be optimized for different customer scenarios, depending on how you package that. So here's an example. One thing we made simple, really simple, is to rename the NICs. So we introduced a feature called consistent device naming. And you can think of this as in the old days when I forget the colors, but the green was the mouse and the purple was the keyboard. And so you knew what ports to plug things into. For those of you that played around in a rack, all those ports look alike on the back of the NIC. And I spent a lot of time playing around with this. And it's embarrassing what I had to do. Just on a server, I don't know what the ports map to in the operating system in Server 2008 R2. So I'd plug in the NIC, and then I'd run into the UI and see, was that NIC connected or not? And then I kind of infer what's going on and which that is. So that goes away now with CDN. So OEMs are allowed to do the colors on those, so red, green, purple, whatever, or just put numbers on the plate, so that number is reflected then back into the OS. The OEM would need to put that into the BIOS. So the naming's there. So that gets you wiring. but those names may not be meaningful to you. So we gave you a simple way to rename them, and so our guidance will be to name them something meaningful like guest traffic, cluster traffic, live migration traffic, and so now I can rename those NICs. Here's an example where I have OEM has a machine and they want to set it up for RSS. So this will be more a native example. You know exactly what the configuration of the motherboard is, see where the NUMA nodes are. So I'm going to rename one of the NICs, NIC 1, I'm going to call it NUMA 1 NIC. And then I'm going to set net adapter RSS. I'm going to set it on the NUMA 1 NIC, I'm going to call it NUMA node 1. And on the other NIC, NIC 2, I'm going to say NUMA node 2, so I'm going to map that in there. So I'm fine-tuning RSS for a high-performance scenario. So this is something that's very simple to do. We encourage the OEMs to go in and fine-tune this for this particular scenario. Again, being able to leverage on the PowerShell that we've built in box. And so this is a simple way. It's PowerShell. These scripts are very tiny that you'll see. You can distribute them to the web or whatever mechanisms that make sense to you. But this is, we really want to encourage you to start using this in your testing, certifications, things like that. Start using the PowerShell. So now let me hand it over to Chris to start talking more about the power of PowerShell, of the networking commandlets, and how you can build your own applications.
All right, hello again. How you guys doing? Hopefully early morning. I'm excited to be here. The lights are in my face. I hope I do a good job. We're going to talk a little bit about how PowerShell provides really powerful objects that you can use both as an application developer and a scripter. A lot of you may have used NetShell that provide a lot of string-based output. It's a fairly powerful tool, but there's a lot of headaches that come with strings. We've gotten a lot of feedback that people have to build these really complicated parsers to use NetShell in a way that's scriptable. It's just a reality of today's world. And PowerShell provides objects, an object pipeline that makes it way more robust in terms of making really complicated scripts or highly sophisticated applications. As I briefly mentioned, we have an integrated object model now in networking. So we have, every time you do get an adapter, get an IP address, you're getting real objects back to the user. That then you can do, use dot notation, run queries, run methods. You can do things. And those objects cover basically the entire stack, all the way from net adapter, as we saw, so net IP address, routes, firewall rules, IPsec rules, even the higher level things like direct access server is covered by an object that you can then run methods on, get properties, and do useful things. It's really powerful stuff. And those objects are linked together, and so you can pipeline something like an adapter and get all the IP addresses, or get all the routes, get all the DNS settings. It's pretty cool stuff. One of the great things about having real objects versus just basic strings is that now your settings are data, right? It's not just text. The real objects that you can save, that you can copy, that you can serialize and turn into an XML. So one of the things that we've kind of run into is you have a safe networking state. For example, here's your adapter bindings. You want this to look a certain way. This is how the computer works. Let's keep it there. But you want to make sure that if something happens, let's say your computer gets nuked, you're able to preserve the networking settings that you've used in your data center for 2 years. You want to know your state. Well, in NetShell, these are just strings, if they were available at all. Now you can take that configuration, serialize it into an XML, save that, and then refer back to that later and even reapply it, right? So take that, the serialized configuration, and if something happens to the server, reapply it and see if that fixes the problem. It's kind of like a sort of back to the future thing that we've done there with these objects, and this happens for free because of our PowerShell implementation. I'm talking a little bit about how you can actually develop applications on top of PowerShell, like the application we showed earlier. There's a lot of different ways to access the PowerShell and WMI work that we built into Windows Server 8. So you guys hopefully may have watched some of the sessions that Jeffrey Snover did on PowerShell and WMI in Windows 8. Our commandlets here are actually based on WMI, on Windows Management Instrumentation, which is based on DMTF standards. So it's a fairly open model, and there's a lot of different ways to access both at the PowerShell level and at WMI level, and that's how we get that remoting. Windows Management Instrumentation is basically, you can imagine, it's a thing on the box that creates on the fly these management objects that you then query against. And when you're running PowerShell commands, you're actually running queries against Windows Management Instrumentation. Nope. Awesome. So you have your PowerShell session, you have the WMI client, and that's running queries against the WMI server. Please get my network adapters, please add a firewall rule, please do this. And there's an abstraction between the client and the server, which is what enables that remoting. And there are multiple ways to access the manageability stack because you see it's kind of spread out. You run get an adapter that hits the WMI client on the box that turns into a query that then runs against the WMI server, which returns the objects. And they don't have to be on the same box. And there could be multiple boxes. You could have 100 boxes, 300 boxes that you're running getting an adapter on and getting all those NICs. What this means is that there are 3 major entry points where you can key into and build on top of network manageability. The first one, perhaps the most obvious, is, again, how we built that application, is really just doing .NET, right? So there are an extensive set of PowerShell APIs that have been available since Windows 7, and those obviously will continue to be available in Windows 8 that allow you to rapidly develop basically PowerShell apps, right? So you take a PowerShell app and it runs get an adapter, and you can interface with those objects easily and do fairly sophisticated things. And then by itself, you can use, obviously, PowerShell directly. I mean, even, obviously, it supports building UIs. You can build complicated scripts. It's a fairly powerful language for doing sophisticated tasks. As an example of how you can use PowerShell very quickly in .NET to do something useful, this is just, again, getting an adapter and printing out the names of the adapters on a couple of remote machines. So you see, we create a PowerShell session. We say we want to run a command, get an adapter on remote machine 1, remote machine 2. We invoke that command, and we get the objects back and print that to the console. And that's it. You didn't have to deal with networking. You're creating a networking manageability tool that didn't have to deal with networking. The remoting is all for free. All the semantics of figuring out what the objects are is basically right there. There's also, obviously, the WMI client side. So Windows includes the WMI client, and you can use the WMI client to generate queries that then get driven against a WMI server. There's .NET APIs that exist today, so from Windows 7, as well as new APIs that we'll be documenting later on around using the session semantics that you see throughout the PowerShell interface. So this is actually going to get easier and easier with Windows Server 8. As well as also the native APIs for using WMI. The .NET API has been historically much more popular because it's really easy to rapidly develop UI tools, but we obviously want to make sure that people have every option available to develop quickly management apps. And lastly, because of the standards-based architecture, there are a lot of third-party tools and third-party WMI clients that can drive against Windows Server 8, right? So let's say that you wanted to build an application on Linux that managed Windows servers. You could do that because our interface is based on open standard, and there are existing tools today, Python, Java implementations that allow you to create WMI queries against anything, including Windows Server 8. And that means all of this new stuff that we've brought into Windows Server 8 is accessible to you using the existing tools. The overall tagline, use what you know. And that's there, it's ready. So as I mentioned earlier, there are multiple entry points and frameworks that make it fairly easy for you to build on top of networking manageability, to write apps, to write scripts, and hopefully automate a lot of tasks that you may be doing, or to develop higher level tools for customers. I'm going to do a couple of quick demos to kind of show what we're talking about, the scope of the work we brought into Windows Server 8 in terms of making networking really easy to manage. Oh. So the first thing I'm going to do, I'm going to open up Hyper-V. I just want you guys all to be convinced that there's nothing there. It's empty. There's no trickery. There's no VMs. It's magical. I am in the background of this demo going to run a script. It's going to be sitting in the background. It's going to be baking. It's like a cooking show. You'll see what this is doing later. It's a secret for now. What I'm going to do real quick is show a couple of commandlets that would hypothetically get some server you have optimized to perform a networking workload. So let's say like a web server run through much the same flow. So I can do something like get an adapter. I can get all the NICs on this machine. You can see the names, the interface descriptions. You see that I have a whole bunch of Broadcom, Intel, Mellanox NICs on this box. You see the MAC addresses. One of the problems we know people have is the names here, right? Especially with all the new PowerShell stuff, we really want to make sure we're giving you something like a Ferrari, really powerful, really fast, not something like a loaded gun, right? We want to make sure that using something like rename, you can know, which NICs you want to manage. You understand what's going on. Make sure you don't, for example, disable the NIC that you're using to manage that machine, right? Yeah, yes, it's dangerous sometimes. So the first thing I'm going to do is rename this NIC. All right, so this NIC right here, I've renamed it. So now it's called Data Center, so that way I can keep myself safe. That's a nice, unique name. And now I want to view the advanced properties for that NIC. And so here's all those advanced properties that I have. So flow control, interrupt moderation, all this stuff, it's grand. One of the things that I want to do with this computer is I want to adjust the NUMA node setup. So right now it's just using the system default. That's not ideal. So I'm going to change it to do the optimum thing for my setup. So I'm going to take a look at what I can do. So there you go. So that's the NUMA node settings. You see, not only do we have the current state, but we actually also support, we show the possible states. This goes back to how you can develop applications on top that would show, what you can configure the system with. It's not an uncontained space. It's contained. OK, so I can see this. Awesome. I'm going to set from system default to something useful. So I'm going to set it to node 1. Awesome. And you see how this command is fairly human readable, right? So set an adapter events property, the name of the NIC, the thing is NUMA, and display node is node 1. Right? Done. Change. That's it. I'm going to go make sure that I did it. So again, yep, there it is, node 1. Everything's working great. Another one of the things we're going to do real quick is that, let's say I have a server application. It's going to bind to all the ports on the box, so not all the ports, all the IP addresses, but I don't want it to bind to the ICE tab addresses. Let's say I only use those ICE tab addresses for management. I don't want my application to bind to those for one reason or another. So I'm going to say all those IP addresses that are associated with ICE tab, I'm going to say skip a source. So here I'm going to get all the ICE tab addresses. See, there's a couple, right? And then I'm going to say set IP address skip as source. And maybe we have a problem. Let's see if that worked. It did, but it didn't work for one of them. So we saw an example of pipelining. You saw an example of an error. So it's a developer preview. So we take one day at a time. You saw what it did do, though, was that it did actually take these ICE tab addresses and did flag them to skip them as source, right? So now my server application is going to bind to them. Awesome. The last thing I'm going to do is that if it's an application that needs to accept inbound connectivity, the firewall is going to block that connectivity. We block inbound by default. for the most part. And so I'm going to create a firewall rule to allow some inbound traffic, right? So let's take a look at all the firewall rules I have. I have a whole bunch, right? A lot of these covering things like remote desktop, Windows Media Player, things like that. I want to make sure I had one for my awesome new application called SuperSpeed. Direction equals inbound. Local port is 2000. Protocol is TCP, right? So it's that intuitive. It's just the line. You say it out loud. You type that into PowerShell, and that's it. Done. See? Awesome. And there's my rule. SuperSpeed, enabled, all profiles, inbound, done. Right? I just made a firewall rule. And I can delete it using remove net firewall rule. Again, it's a real object. You can save that firewall rule, take it to another box, and configure it there if you didn't want to use group policy. And it's really powerful to treat these things like real objects. The last thing I wanted to show is, let's go back to Hyper-V. While I was doing that first demo, you can see we've got a whole bunch of VMs, right? Awesome. You guys know about the Hyper-V PowerShell stuff that we brought into Windows Server 8. It's really exciting. But what do those VMs do? I'm going to go back to Mr. Deck. And what that basically 90-minute script, and we've timed it, did was create this entire setup that you see here, all correctly routed with static IP addresses, everything set up. And so I don't know if you had the opportunity to use the hands-on labs here at Build, but those are all actually set up using the PowerShell that we have here. That's how we were able to automate those setups, right? So if you're building, say, your prototyping application and you want to create a simulated internet, right? You can see how with Client Hyper-V, right? And with all the PowerShell we built, you can easily just simulate any kind of environment you really want, right? Or for the data center environment, woo! Oh, that's good. That's a good moment. And you can see from the data center environment, you can also obviously build very sophisticated setups very, very quickly using the Hyper-V file systems and networking PowerShell. It just all kind of comes together. And again, these are everything's routed. You guys, it's crazy when you build a script like this and you go and you turn on the VMs and they actually can send packets to another, right? No netshell, just done. That's it for the demos. I'm going to let Ross do a little bit of a recap.
Great, thanks, Chris. So we've invested heavily in PowerShell for Windows Server 8, really looking at cloud. And when we say Windows Server 8 is the most cloud-optimized operating system out there, this is a main part of it, that we can actually manage it. We can manage it at cloud scale. So how do we go about do that? It's PowerShell. And we showed you how easy it is to do that. Right? The remoting is shockingly simple. And I really mean that. And as we show customers this, how they can get to the remote machines to manage the networking subsystem. Everybody's surprised, a bit skeptical. That's fine. Go home. We gave you the bits. You can play with it. We showed you how to get kind of the help around that. Hopefully it's intuitive. But again, if you have any issues with this, contact us. We want to help you build products on top of the PowerShell. When we look at the data centers, it no longer makes sense to go in and TS into every single box to do configurations. We talked to a lot of people. We talked to people managing Microsoft data centers and how they go about it. How do they go about getting the initial configuration set up? Now it's very easy. With PowerShell, you can go and set all those NIC settings, the stack settings, the firewall rules, things like that via PowerShell. So in-house, we're starting to use this. So if you're building a management product and driving towards a lights-out type of management product, definitely that was the scenario we had in mind by providing the PowerShell. Scalability is important to us. We're still doing performance tuning on this. We'd want you to go out and try out scalability with the networking PowerShell. If you have any concerns, let us know. I mean, that's definitely something we're very interested in. How big is that scale, right? And so we're working in-house to figure out what those performance numbers are. It's still early on in the cycle. Kind of traditionally how we go out developing our product is that we get it feature complete here. That's what the developer preview is all about. And now we go into hardcore scalability and performance testing. But any feedback you have on what we've given you today in the bits, we're very interested in hearing from you. Choice is very important. a lot of our messaging you heard at the show here is standards-based. And so WMIV2, DMTF, standards-based here gives a lot of flexibility. That flexibility comes from giving you the choice of the developer platform that you want to use. And I know it's always, you're always skeptical with the demo how easy is something to build. And so we encourage you, you'll see the code snippets that we have here, that you can go out and start building your own types of GUIs on top of the PowerShell, so that you can actually see how easy it is to do. And we definitely encourage that we all win together if you build on top of the PowerShell that we're providing. And let us handle kind of the low-level management stuff, the networking stuff. And as Chris mentioned in the demo, he was doing network management without having to worry about networking. That's all transparent and very, very simple. So the call to action, we've said this again and again and again, so hopefully you're hearing this multiple times. We really want the IHVs to manage your advanced properties through the PowerShell that we're giving you. And I showed you an example of using new NetAdapter advanced property. Semantically, we have no idea what you're doing in there. We just don't know, but we're providing the management framework for you to innovate on top of that by letting us handle the management aspects of that. Make sure that your commandlets work. Please make sure they work. It's very important. And so we have some rules about where the registry keywords must live in the registry. Back into that 72 and the GUID and exactly where in the tree it needs to live. So make sure the advanced property commandlets work. VMQ, RSS, all those things. In your testing, you should be now using our commandlets to make sure that passes and manage it that way. For OEMs, I think there's a real opportunity here to optimize your products based on all the knowledge that you have. Again, you know the motherboard, you know how much memory, you know the NICs, you kind of know the scenario that you position that product. So it makes everybody look better, and solves the customer problem if you can say, look, I have a SQL-based SKU and I want to tune it. This is high performance. I'm going to have 4 10-gig NICs in this because I really need to consume all that bandwidth. Low latency is important. One thing that we've introduced now is RDMA in this release. So we have RDMA commandlets, the NetAdapter RDMA. So everything that you see, all the features that we've introduced are PowerShell manageable. You as the OEM, you know exactly what the capabilities of the NICs are that you put in your product. So you can fine-tune them and tweak them so it makes a great customer experience. If you're building management tools, again, you can now build data center management tools, and we've abstracted out a lot of the low-level networking stuff for you. And again, though it's hard to believe, but dash sim session, the machine name, and everything is just working. I mean, it really is that simple. So we want to make you successful. One thing, we're in the feedback mode, so if there's something that we missed, we want to hear that from you. So how can we make this better? And then, we're not done. So after Windows Server 8, Synopsys is always famous for saying there will be something else coming out. And so, it's a good time to provide feedback. Did we miss anything when we were thinking of the scenarios? Is there something managing the cloud that we need to fix? It's a good time for us to get that feedback. Some related sessions. This is historical in some sense. You can go back online and look at these, but we had a talk yesterday talking about all the advanced properties and the new NIC features that we've introduced. Things like receive segment coalescing. So obviously, because that's important to us, NetAdapter RSC is one of the commandlets that we have. RDMA, the QoS. All those are commandlets that we provide. So that you can go back there to see everything that we've introduced here in Windows Server 8. Higher level management sessions. Jeffrey Snover gave some talks. So making your product manageable and then a highly efficient environment at scale. So our talk, and we were kind of very siloed in our thinking in this talk about networking, but also Hyper-V, file server, across Windows Server, we're all adopting and moving towards PowerShell. So we want everybody with us as we do that. There's some further documentation and reading. Again, there's not a lot of documentation on what's in there now, and so we showed you some tricks, basically almost self-documenting there, but we don't have the detailed documentation ready yet. So again, contact us and we'll help you be successful in what you need to do to start building on top of the PowerShell. And there's an alias that we'll be monitoring, netman@microsoft.com, so network manageability. And so we do care a lot about this, and we do want to work together with the community on how we can enhance PowerShell. And that's pretty much it. I know we're finishing a little early, so we do have time for questions if there's questions. Yes. So the question is, what version of .NET, Chris?
I believe the first version of .NET that supported the PowerShell semantics was 3.0. Absolutely. The application I showed you actually works on Windows 7. It has to be driven against a Windows 8 machine, but the application is using APIs that have existed since at least Windows 7. Yeah, the PowerShell APIs. It's running a PowerShell script, right? Yeah.
Yes. Yes. Not in this release, but we do have commandlets like disable net adapter, and we'll ask you, are you really sure you want to do this? Also, we think we can work around this with guidance. So for us at Microsoft, typically we call it CorpNet, is what we're on domain join. And so we would rename that net CorpNet so you don't accidentally do something to it. Now when you tweak a NIC, most of the time you need to restart it to get the advanced properties to stick. And that's exactly what happens in the UI. So we've replicated that same semantic and experience in our commandlets. But we put in optimizations for you as well. So instead of, let's say I have to set all, like 20 different properties on a NIC. I don't want to set a property and restart it, and set a property and restart, which is what you do actually in the UI every time you click something. But we provided a parameter called no restart, so that you can go in and set these parameters, and the way you would use that, you'd say, property 1 dash no restart, property 2 dash no restart, property 3 dash no restart. And either you can leave the dash no restart on the last property that you set, and then we'll restart the NIC for you. Or we have a commandlet called restart net adapter, and it'll restart it. And that's kind of the fun thing about playing with the PowerShell. Hopefully it seems intuitive. If there's something that you need to do to the NICs, or one of these commandlets, hopefully there's a verb-noun pair that's pretty close to what you would expect it to be, like restart net adapter.
I actually wanted to clear up real quick the earlier question about using .NET. So there's two .NET APIs. There's one for interfacing directly with PowerShell and one interfacing with WMI. Interfacing with PowerShell is currently pretty difficult to access the Windows 8 stuff because the commandlets aren't on Windows 7. So you generally have to use WMI if you want to manage from Windows 7 into Windows 8. Not right now. We're still having conversations about what kind of support we want to down level, if any. So. Yes. Yeah. Yes, we understand. People always want things. We always like to give them, but there has to be a balance.
Yes. Yes. Sure. We have a feature called consistent device naming. And what that is a mapping in the BIOS from the actual NIC port to the name of that NIC. And so we've just provided a base mechanism. It's up to the OEMs to take advantage of that. So instead of us pre-populating our default names like wired Ethernet connection, 1, 2, 3, 4, that kind of thing, that name will be by default whatever the OEM decides it should be. And again, because the OEM knows exactly the NICs and the configuration, the layout, and the PCI port numbers, they can go in, or the slot number, sorry, they can go in and say, this slot number is actually mapped to this physical connector on the backplane of the server. And whether they write that with a 1 or a 2 or a character or a color, that's all up to them, but we've given them a mechanism to do that. And so that will be the name of the NIC that you would see. So if I said get net adapter, I would see with those default names instead of wired Ethernet connection. Yes? Yes, that's all up to the OEM to provide that information to us. Correct, correct. In that case, we would go with wired Ethernet connection, the next one. But our guidance, user guidance will be, you should rename your NICs to something meaningful. The wired Ethernet connection is not very meaningful, except maybe the very first time you boot up the machine to know that where it is and play around with it. But you should rename it. So again, like cluster traffic, gust traffic, something like that. We would encourage everybody to do that so that it's more meaningful. And you saw how simple it is. Again, it should be, if there's, it should be an intuitive commandlet. Rename, not adapter.
For example, plugging in a 4-port NIC,
Mm-hmm.
because the device enumerations all done in parallel, sometimes you'll get LAN connection 1, 2, 3, 4, matching in 4 ports.
Yes.
It'll be entirely the wrong way round.
That's only the first time. Then the name sticks that we give it to you. And your name will stick. So once you get that, I understand there's a bit of tweaking that you need to figure out where that maps. If you're not using CDN, then you need to figure out where that port is on the backplane. But once you rename it Live Migration NIC and you know what it is, then that name sticks forever and you reboot, it's okay. The problem that we had in the past is the very first time you booted up a machine, it was non-deterministic what names got assigned to where on the ports. But once we booted up, that was deterministic. But it made it very difficult to script around this because you had to go figure out what names we picked. And that, again, was non-deterministic. CDN makes it deterministic. And so that's the advantage. So now I can use CDN as my starting point. I now wire up my network, the backplanes this way, and then I can rename those. So let's imagine that an OEM went with colors. And so there was a blue port on the back. And your blue port happens to be Live Migration. You should then name blue Live Migration because it'll be meaningful to you. So then when I do a remote, so I get that adapter on the remote machine, I would say this is the Live Migration NIC. And it may be important to me because I may have different settings on that NIC tweaked for Live Migration versus the gust traffic. So the example would be, let's say I have RSS on Live Migration, so that's parent traffic. But I definitely want VMQ on the VM switch side. So I want VMQ and make sure it's enabled on the gust traffic NIC. And RSS and VMQ don't coexist on the same NIC at the same time today. And so that would be an example where semantically, we don't necessarily know what these NICs are being used for, but by renaming them, you make it a lot easier to administer. And so if you're building a data center management tool, you can make that very easy for your users to do this. And honestly, as we showed people how they can leverage the PowerShell, we really have, and I'm not exaggerating, we put smiles on the faces of people who typically yell at us. So I think there's an opportunity here for you to also delight your customers by managing the data center, the networking subsystem in the data center very, very easy.
So we're basically out of time. There's one hand. We're working on providing a whole set of PowerShell examples, including ones like the one I showed you. Yes, so working on it.
Great. We'll stick around after the session if people have other questions. But thank you.